Okay. Let's say my paint screen visible, guys? Now is it visible? Okay. So let's say these are two different laptops. Two laptops. This is machine one, laptop one, and this is the laptop. Now this laptop one is owned by a rich guy, but who's academically very weak, financially strong, but academically weak. Okay, so it's owned by, let's say, Rajesh, who is financially strong. So he's having a very high configuration laptop, but academically he is very weak. But the laptop configuration is very high. Okay? Maybe he is using uh, 32 GB of 32 GB RAM. Okay, and some very high speed processor. Okay, let's say assuming X speed of that, okay, let's say 10x speed. And other also higher configurations are there. And this person, second person, okay, let's say Alice, is on the flip side academically very strong, but financially not that strong. Okay, so instead of writing weak, we can say financially not strong, but academically she is very, very, very strong. Okay, very, very, very strong. So, but her laptop configuration is not that big. Maybe she's having a 4 GB RAM, and if this is the 10x speed, this laptop is 1x speed. The CPU speed is one time the speed of Rajesh's laptop, right? So naturally, Rajesh's laptop will execute the processing speed is higher. So if I ask both of them to write a code, let's say I ask both of them to write a code to check whether the number is a prime number or not. Okay. Now they both write a code and they both get the correct output. Okay. Let's say Rajesh copy pasted from some site and the output. So if I enter 7, if I enter 7, it says it's a prime number, and if I enter 10, it says not prime number. Output they both are getting. Now if this laptop is faster, maybe the output may come in 1 second. Just I'm thinking loud to myself. Okay, or it might come in 1 millisecond as it is faster. So as Alice's laptop is 10 times slower than Rajesh's laptop, Alice might get the same output, but in how many? 10 milliseconds, right? As this laptop is 10 times faster, right? So if they are, so now does that mean that Rajesh's code is faster than Alice's code because the output has come fast? Is this the parameter to judge the speed of execution of the code? Naturally, if the hardware is superior, if someone has a very superior hardware, naturally the execution speed will be higher of that machine. And if someone has a comparatively slower hardware, the output will be comparatively slower, right? So we do not judge the software performance based on the hardware. So then how do we judge which code is faster, whether Rajesh's code is faster or Alice's code is faster? We judge them by the number of primitive operations both the codes are performing. Yeah, by what do you know efficiency? Number of number of primitive operations, okay, which the code executes. That is the way we judge which code is faster. Okay, so let's say in prime number, okay, see when I say 3 times 5, what am I doing? Which arithmetic operation am I performing? This is multiplication. But the primitive operation of multiplication is addition. Behind the scenes, the calculator to achieve multiplication, it does addition. What does it does? It adds this number this many times, correct? So behind the scenes, what is happening? What is a primitive operation for a multiplication task? So if I am trying to do multiplication, the primitive operation, the basic operation that is called as primitive operation is addition, correct? So this many times. So the task is multiplication. The task or the job or the program is multiplication. But to achieve this task, the operation which is done internally behind the scene is what? Addition. So what is the primitive operation for multiplication? Addition. Okay. Similarly, I want to check whether the number is prime or not. So the primitive operation over here is comparison. Is what? Comparison. Because I will compare that whether the 7, so the number, which number is prime, which from 1 till itself only divide how many times? A prime number, let's say if I'm assuming 7 as a prime number, so 7 will divide how many times? From 1 to itself will divide only 2 times, right? So I will check at every operation 7 mod with 1. Does it give me 0? So I'll increment the counter. So I'll take a counter variable. So I'll take the counter variable, initialize to 0 and increment the counter. So what will the counter become? 1. Then again I will keep on comparing 7 mod with 2. Will it give me 0? So what is the primitive operation I am performing to check for prime? I am comparing, right? Yes or no? Comparison. So the number of times I will compare. So if Alice has compared 3 times. Even though her answer, because of our hardware restriction, took 10 milliseconds, but she has done the primitive operation of comparing 3 times. And Rajesh has got the answer, but he has done the primitive operation of comparing 300 times. Just because his hardware was superior, so he got the output faster. But his primitive operation of comparing was 300 times he had done the comparison. So now, what will we say as software engineers? Whose algorithm is faster? Is it? Very good. Whose algorithm? Alice took only 3 primitive operations, and Rajesh took 300 primitive operations. So, who is faster? The one who has taken less primitive operations to achieve the task. So, less, less number of, okay, compare primitive operations to achieve the task. So, we will conclude that Alice's code is 100 times faster. How many times? 100 times faster she is to Alice. Okay. If she would get the equal hardware, if we would get equal opportunity, and if even if Alice could buy such hardware, then we so now, but this is not practically possible that every person is using the same hardware. So we eliminate the hardware from the equation to judge the speed of the algorithm. So irrespective, someone is on a comparatively weaker hardware, but that doesn't mean that, so that has nothing to do with the performance of the algorithm. Performance of the algorithm is judged on the number of primitive operations you are trying to achieve. Okay, so let's try to take some practical examples of this to understand things better. So prime number is a perfect example to understand and explain what is your time complexity. Okay, so someone's mic is, if he or she can unmute it. So 7 mod 2. So if the number is divisible by, this is my I, okay, my I will iterate from, will start from 1, will go till the number itself. And I'll keep on checking at each iteration. So I'll be writing 7 mod n mod I. So what will I write over here? N mod with I. If it gives me 0, I'll increment the counter. Counter plus plus. Okay, this is the code I'll write. So does 7 mod with 1 give me 0? Yes, counter plus plus. 7 mod with 2 gives me 0? No. So counter doesn't increment, counter stays the same. Likewise, 7 mod with 3, will it give me 0? No. So counter still remains the same, it doesn't increment. Will 7 mod with 4 give me 0? No, right? So counter still remains the same. So I am comparing. So how many times do you think I will compare? I will compare n times. So if the number was 13, I would make how many comparisons? 13 comparisons? 1 to 13. Okay. So here 7 mod with 4, will it give me 0? No. So counter still remains your 1. Then with 5, does it give me 0? No. So counter still remains 1, doesn't increment. And does 6 give me 0? No, right? So my primitive operation of comparison, how many times have I done the comparison? N times? No. How many times will I actually do it in the end? What the number is 7. So I've done how many comparisons? 7 times. So n times rather, right? So now we'll generalize it. We'll not take it specifically. We'll put it into a formula. So now 7 mod 7 gives me 0. Yes. And my counter will increment by 1. It becomes 2. So my question is, how many times have I done the comparison activity? N times. Yeah. So if n is 7, then 7 times. What if the n was 25? Then 25 times. Correct? Right. So maximum comparison I will do is n. So when we say a maximum comparison, then we use the O, big O notation, and we will say the time complexity of this algorithm is O of n. Means this will take n number of primitive operations to achieve the task, right? Am I understood, guys? So let's try to code this. Okay. See, I've also installed the IntelliJ IDEA. This is one of the most widely used IDE by developers. Okay. So we have students and we have professionals. So students academically, we Eclipse very good. But if you want to venture as professionals, then try to install IntelliJ IDEA. Okay, it comes in two versions. Community version is free, and IDEA Ultimate is a paid version. Initially, even if you can get hold of the free version, is fine. Okay, so try to research on this. Try installing multiple IDs and practice. Okay, so as we have begun on Eclipse, we'll try to go ahead with Eclipse. Once the majority of you all are comfortable with IntelliJ IDEA, then we can migrate to IntelliJ IDEA. So both are equally good IDs, but professionals use a lot of IntelliJ IDEA. Okay, so I'm using today day 9, and I want to show time complexity. How to calculate the time complexity of an algorithm. Very, very, very important, very underrated, and very important topic to discuss. So class, I'll say prime number, and I'll add main to it. Okay, so I'll not waste time in accepting the number from user. I'll directly hard code the number. The number is 7. Okay, now from where will my loop start from? A loop will start from 0. Very good. Who's this? Who's this? Who's this 0? Did my loop start from 0? Guys, I would want you all to join from your laptop. Please switch on your cameras, everyone. I want to see who joined from the laptop. I want everyone to switch on their cameras by the count of 5. 1, 2, 3, 4, 5. Yeah, and I will realize that majority have joined through phone. If this is the seriousness you all are showing, who joined from laptop? Abdullah joined via. So I will start from where? Where was I starting from? Who said 0? I starting from 1. So 1, right? I equal to 1. I less than or less than equal to n. So n and I plus plus, right? We're incrementing by 1. Now I also need a counter variable, correct? And then what will I check? If my 7 mods with 1, 7 mods with 2, 7 mods with 3 means if my n mods with I and gives me a remainder of 0, what will I do? I'll do counter plus plus. Now as there is only one single statement in this, you can skip the parenthesis. Okay. And then outside the for loop, we will check the value of the counter, correct? If counter is equal to 2 means this out, it's a prime number. And if it is not, else this out, it's a not prime number. Okay. Easiest algorithm, simple, user friendly. Okay. So let's run it and check if everything goes well. And for 7 it is giving me prime, that is absolutely correct. And for 70 it will give me non-prime. Make sense? Now to tell that 70 is not a prime number, how many time the iteration happened? This is the primary primitive operation, right? Comparison. So if I now take a integer loop counter, okay, that is to keep the count of the primitive operation, I take a loop counter variable, initialize it to 0, and I increment each time the loop iterates so that I can count the number of primitive operation it took to achieve this task. And if I sys out and I display the loop counter, let's check. So it is telling me that the number is not prime, but how many iterations is it taking behind the scenes? Why 70? Because this is working in which time complexity algorithm? So as hardware is not the parameter, yeah. So as hardware is not the parameter to judge the speed of the algorithm. Okay. So how much time that algorithm took to return the value is not a parameter because time will vary depending on the hardware. So if Rajesh has a superior hardware, naturally his time will be less, right? So the mathematicians or the computer engineers, they've devised another measuring unit called as asymptotic notation to measure the time the algorithm takes to execute, eliminating the hardware configuration. So it's called as asymptotic notation to measure the performance of the algorithm, how much time the algorithm takes to execute. So one most widely used asymptotic notation is big O. Is what? Big O. Big O gives the worst case complexity. In the worst case, how many primitive operations you will take. Okay. Worst case. So big O will always give you the worst case. So if you mention the complexity in big O means that is the highest number of primitive operations it will take. It will not take more than that. And we have to give it in a generic formula based. We cannot give we cannot say I will take O of 7. This doesn't work. Okay, this is constant time complex. So in big O now we have various complexity classes. Okay, so now in big O we have various complexity classes. So try to get hold of these terms. It will be very helpful for you when you go for the interview. So if you can discuss your program and your ideas with the interviewer and use these jargons, big O and time complexity, naturally it will impress the examiner. And it is a no compromise for the experienced guys. But the freshers can also start communicating in this terms, time complexity and big O. If you all can use these jargon in the interview or in your Viva. So now we have complexity classes. Okay, you all can research on this and see if you all what you all understand from your research. I'm trying to explain what I have understood in this. So if there is a task which will take fixed amount of time always. So if I have an array and if I say display me the first number from the array. So now this array is of size 3, if this array is of size 4, if this array is of size 100, size million, it will always take the fixed amount of time because I just have to display ARR of 0, correct? To display first number from an array, how much time will it take? First value from an array. So if that array is of size 3, how much time will it take to display the first value? ARR of 0, correct? If the array is of size 5, then will it take same time, right? So that is called as constant time complexity. That is called as which class? Constant time complexity class. So that class which will always take a fixed amount of time irrespective whatever size of data we have. Okay. So we can say this as O of 1. So the time complexity to display the first number from an array is be what? O of 1 fixed. Next is linear time complexity. Next is what? So if I ask find the sum of these array. So if I give you an array and if I ask you to find the sum of the array, what is the primitive operation in finding sum? What is the primitive operation in finding sum? Addition, right? So how many time will you do the addition? So you will say I'll say integer I equals to 0, I less than arr dot length I plus plus, and you will take a variable sum. Okay, initialize it with 0, and then as the for loop contains only one statement, you can skip the curly bracket. This is the code you will write, correct? So which is a primitive operation happening over here? Addition. So how many time will this happen? 5 10. If the array size is 5, if the array size is 10, then 10. So that is called linear time complexity, depends on the size of the data. So the time complexity of sum of an array is O of n. O of, will it ever do more than 5 additions if the array size is 5? Never, right? It will never exceed that. That is called as linear time complexity. So if one developer solves the problem in linear time complexity and one developer solves the problem in constant time complexity, whose is faster? Whose is faster then? So your O of 1 is less than O of n? Yes, no, maybe. So this one is faster comparative to O of n. This is your linear time complexity. Then you also have, let's say, quadratic time complexity. This is a third complexity class. This takes, what is the quadratic equation, Umar? Where x ka power is 2. So this works in n square. If the size is 2, the algorithm will take max to max n square primitive operations like bubble sort. Like, so if I have bubble sort, we have two nested for loops, remember? So when if I want to sort this data, what do? I have to run two. I have two for loops. Okay, like addition of two matrices. Let's say addition of two matrices. So if I have this matrices 1, 2, 3, and 4, and if I want to add it with another matrix 4, 5, 6, 7. So how will I write this code? There will be two for loops, right? One for the row, one for the column. How will we write this? I equal to 0, I less than 2, I plus plus. Then inside that, j equal to 0, j less than, j equal to 0, j less than 2, j plus plus. And then we will say matrix 3 of ij equals to matrix 1 of ij plus matrix 2 of ij. So how many times will this addition happen? If there is a loop inside the loop, it is multiplication. So this will run two times. This will run two times. So 2 into 2 into 2. 2 into 2, how many? 2 into 2 what? 2 into 2 is 8. Wow. 2 into 2 is 8. So that's why if the array size is 2, the 2, then it will take 2 square times maximum. What if it would have been a 3 by 3 matrix then now? What if the matrix would have been 3 by 3? Then how much time would this algorithm, how many primitive operations would it take to add these two matrices? 3 by 3, that is what? 3 square times, right? So that is called as quadratic time complexity. Okay, we missed one complexity class very widely used, logarithmic time complexity, and that will come between the constant and the linear. So as I'm going down, the speed is getting slower. Okay, so this is the fastest, then slower, slower, and as I go down, will become further slow. So between your constant and linear, there is one very famous, very widely used time complexity called as logarithmic time complexity. Okay, so if I have a value n, okay, let's say, have you all done binary search? So binary search, what does it do in each iteration? It will filter out the unwanted data. See, to understand binary search, let's understand this is a telephone directory. This is a telephone directory. Some countries call it yellow pages. Okay, and it gives you the telephone numbers of all the residents of that city. So let's say this is 1000 pages and it is always sorted in ascending order. So all the A's, surnames will come at the start, then how we have a roll call, then all the B's, then in A also, A, B will come first, A, C will come later on. So it's alphabetically sorted. So the last few pages will be for Z, correct? So, uh, so which is the 13th alphabet? M. M will come in the center, correct? Okay. S will come towards the right of M, and J will come towards the left of M, and D will come towards the left of J, and U will come toward the right of S. So now, okay, this is given free of charge. Okay, so then the people don't charge for this. So you can take 10 telephone directories and go and do whatever you want to do with it. So let's say now if someone wants to search for a name called as, okay, let's say someone wants to search for any U name. Okay, let's someone wants to search for Umar. Now what we do normally is we'll open the book from the center. So which page will open? M. So let's say M was a 500th page, right? So what will he see on that page? He will see all people with M, Mike, and all those people, blah blah blah. Now what will he think to himself? The name which he is searching for is in which side, left side or right side? The name which he is searching for is in which pages? 1 to 500 or 501 to 1000? Where is it? So what that person will do, as it is given for free of charge and doesn't is not much expensive, he tears the pages 1 to 500 and throws them away. Now how many pages does he have to search from? Initially, how many pages was he searching from? So the first search was from 1000. Now after searching for Mike, how many pages to search from? Half, right? Then he again removes the half. Okay. Then he searches the page 750, and in that 750, let's say he's searching for some Y. Okay. Let's say he's searching for Yakub. Then he will open at which page he will open, which is at the midpoint of 501 and 1000, 750. So if 750 he opens, he sees U. Okay, all the names with U. So where will he search now? Towards the right or towards the left? If he's searching for, so now he will again tear these 250 pages and throw them away, right? Then how many pages left now? So at each iteration, what is he doing? Tearing away the half, okay? Reducing the data into half at each iteration, correct? Yes, no, maybe. So if this is your algorithm, then it is called as logarithm. This is called as logarithmic time complexity. So can someone tell me what is log 100 to the base 2? It is you take the number 100 and you recursively divide it by 2 till you get 1. So 100 by 2, what will you get? Yes, guys, someone be there with me. 50. 50 by 2, 25. 25. 25 by 2. Okay, remove the point 0.5. Let's carry the point 0.5. Let's carry the point 0.5 above. Let's keep it this integer value. 12. Now 12 by 2, 6. 6 by 2, 3. Okay, 6. So recursively keep on dividing by the base. This is called as the base, right? The base of the logarithm. So this is log. What is the base? 2. So you constantly divide the number with the base. So this will give you 3. Then again, as till you have to go till 1. Okay, 2. Now 1 has come. Okay, and the point 0.5 again gets carried forward. Correct. So if I join these two point 0.5, I will get one more 1, right? Assuming. Now, how many divisions have I done to come till 1? Count the division now. 1, 2, 3, 4, 5, 6, right? And if I accumulate these two, so maximum how many? So log, so you can say log 100 to the base 2 is 7. It is 6 point something, but roughly I am saying 2. That's roughly I am saying 7. It is equal to 6 point something, which will be equal to approximately equal to what? Am I understood, guys? So those algorithms which constantly split the data into half. So earlier I have to search from 100 numbers, then I have to search only from 50, then 25, then 12. So at each iteration, the data is being split into half, divide and conquer. So those algorithms, they work in which time complexity? Logarithmic time complexity. Most of the time it is to the base. Most of the time it is to the base 2. Okay, now can someone tell me? Let's see how good you all are at logical reasoning. Now is a litmus test of you guys how you all are good logical thinkers. What is log 200 to the base 2? So if log 100 to the base 2 is 7, log 200 should be 14, right? Approximately 14. Yes, Anas. Why no? Why no? If 7, if 100 is 7, yeah, because it will just increase one iteration, right? So 200 by 2 gives me 200 by 2 gives me 100. So just one iteration has increased. So log 200 to the base 2 will be how much? Only max. So if max to max, it is 2. Okay, to the base 200 will be approximately 8. Okay, approximately you can say 8. Will be some 7 point something. Approximately you can say 8. Okay, now let's see what is the log 100 or log 1000 to the base 10. Now tell me. This is very simple. How many zeros are there? How many zeros are there? That is the answer. That is the answer. Because if I take 1000 and recursively, if I take 1000 and recursively divide by 10, what do I get? 1000 by 10, 100. 100 by 10, 10. And 10 by 10, I need to come to, so how many iterations have I come? How many did I need to come to 1? That is the so that's why the logarithmic time complexity will be between which two? It will be between the linear and the, where is it? Where was the writing on that stuff? It was in this page only. Okay, is this what is the left? Yeah, so over here. So your logarithmic will be between 0 and 1. Because if I say log 100, if I say linear of 100 will be how much? If n is 100, what is linear of 100? If the if the n is 100, let's assume n as 100 everywhere. So if the array is of size 100, to find the first number, how much time will I take? How many comparisons? So let's take a n as 100 as standard. So what will be log of O of n? 7, right? And 7 will fall between 1 and 100 because O of n will be 100, O of 1 will be 1. Then what will be O of log n? What will be O of log n? Log n means by the base 2 normally. Normally when I say log n means to the base 2. So what should be the answer for this? If the value of n is 100, constant will always give me 1, linear will give me 100. So what is log 100 to the base 2? 7, right? So 7 is following between 1 and 100. This answer is 1. This answer is 100. So where does 7 fall between which two numbers? So that's why the logarithmic time complexity falls between constant and linear. And if the size is 1000, what will be the quadratic? How many steps? 1000, 100 raised to 100. How much? What is 100 raised to 100? 10,000. That is multiply by 100 multiply by 100, no? Will be how much? 10. So it will take 10,000 steps. Then you have cubic time complexity also. Which one? That algorithm which will operate in cubic time complexity. Means if the data is 3, it will take 27 steps. That is cubic time complexity. That will be what? Time complexity will be O of, tell me, O of n cube. This is matrix multiplication. So matrix multiplication works in cubic time complexity. Because to multiply two matrix, you have to run three nested for loops, I, j, and k. And the most slowest is your factorial. Factorial time complexity, most slow. So let's take the number 6. Let's take the number 6. Let's not take 100. Let's take 6. Okay. Let's take n as 6 and check. So if the array size is 6, to find the first number, how many steps will I take? Yes, no, maybe. 1. And if I work in linear, I will take how many steps? To find the sum of that array, that is 6 steps. Okay. Yeah. And if I want to do a binary search on the array size 6, will be what? 6, 3, 2, what? 3 attempts. So one is falling between 1 and 6. 3 attempts should be maximum. If quadratic means 6, will take how many steps? How many? 36. Cubic means, what is cubic? What is 6 into 6 into 6? 36 into 6? 216. And if factorial means O of n factorial, how much? 720. What is 6 factorial? 720, right? So n factorial is the most slowest. So if now two developers come to me and they show me their code and they show me, sir, developer A, he says the same task I have done and my time complexity is O of n factorial. Irrespective of whatever his hardware configuration is, I am least concerned with that. And developer B says that my time complexity is O of, or he says log n. He says my time complexity is O of log n. So who will I say is faster? A or B? B is faster because, so if I give B a data set of 6, A will take 216 primitive operations, the other 720 primitive operations. So this will come how much? 720. And the same task B is doing it in only how many iterations? 3 iterations, right? So he's around 240, 220, 240 times faster. So B is how many times faster? B is 240 times faster. If the data set is of size 6, if the data set is of size 6 and A says my I am taking O of n, means how many steps? Worst case 720, and B is saying I'm taking log of n. So B is saying how many steps? So what is the ratio of 3 to 720? How many times faster? 240 times 3 is right. So B is 240 times faster. Not only fast, is super fast. Now, irrespective if B is having a old laptop, that doesn't make a difference. And if is having a new laptop, a latest laptop, that hardware we have removed from the equation. Okay. So this is the same thing I wanted to show you all over. This is a theoretical concept. So get the theoretical concept in your mind clearly. Now let's do the practical. So this was one algorithm of doing it. There's one more algorithm. Okay. So there are many ways of doing the same code to improve the performance. Okay. Now I'm going to prime number 2. So this is confirmed that a prime number will divide by 1 and by itself. Correct? Is my screen visible? So this is guaranteed that every number which is prime divides by 1 and by itself. Now, which are the numbers which are left? Which are the numbers which are left? These numbers. So, if a number divides anyway between these, like if 7 would divide from 2 to n minus 1, right? It would not be a prime number. If if 7 would divide by any number in this red zone, would it be a prime number? No, right? So, what I can do is I can now use a different algorithm and say instead of going from 1 to n, rather we go till 2 to less than n and then check if it divides over there. So if my n mods with I and it gives me a 0, means it is not a prime number. So I'll take a flag value and set it to 1. So initially I'll have a flag. So instead of a counter, I'll take a flag. And do I need to search further? So if I take the number as 100, if I take the number as 100, 100 by 2 gives me 0. So will I check with 3, 4, 5, 6? Will I check with 3, 4, 5, 6? No. So I'll just break over there, right? So once I get the number is divide, I'll say flag is 1 and I'll break. And outside the loop, I'll check the value of the flag. If the flag is 1, means this is the indication it is not a prime number, right? The flag is 0 means, and I will check the number of time the loop is iterating. So I'll put at the start only I'm putting the loop counter plus. Okay, now let's check on the same data 70. Let's check the same data 70 and see how much time it is telling me that it can tell the 70 is prime or not. Okay, see, it's checking only how much iterations. So can I say this algorithm is working? So can I say this is working in O of n, O of 1, constant time complexity? No, I cannot say it. What if I take a actual uh, prime number. Is 91 prime? So now, see, this is checking what? Not prime, but how many iterations it is taking? 6 iterations it is taking. Had it been this algorithm, it would take how many iterations? 9. So that would work in O of n. Now, this, if the number is prime, so give me a prime number. So for prime number, this is 17. For prime numbers, it will take how many iterations? Okay. For prime numbers, how many iterations it will take? No, for prime number, it is skipping one, it is skipping itself. What is left? See, this will not be true for a prime number, no? This will not be true for a prime number, this condition. So the entire loop will be executing. So for 17, how many times will this loop run? For the number 17, how many times? Because it is starting from 2 till that. So one is eliminated. Yeah. So yeah. So this is if I run this 15, right? So it's telling me 15. So we have to take the worst case, right? You cannot take the best case in O of n. So you will say this algorithm is working in the time complexity of O of n minus 2. It will not take more than this, right? So now which is, so if this was working in O of n, this is working in which time complexity? And in this, so in this is a significant improvement. If not a tremendous improvement, there is some improvement. Okay, then the third developer comes and he says, I can do it even faster. So what he does is, he observes that a number max to max will be divisible by its half. So 100 will be divisible by 50, right? 100 biggest factor is 50, right? Will 100 go in 51? Will 100 go in 51? So he says, why are we wasting the iterations beyond the half? Start from 2 and go till n. Just check over there. So he just puts this n by 2 over here. What does he put over here? That just go till the half and check. If it divides till there, it's good. So now the same 17 which you will check will give you a prime, but it will take in only half the iteration. Got it? So this person says my algorithm is what? N by 2. Is it not faster? So now if I want to check the number 121, is it prime? So it's for not prime, it is taking maximum 10, but for prime it will go till the half because here it is breaking. So if you have 1000, how much time will it take? Only one, right? For 1000 by 2, so in one step you will say number is not prime. But for prime, so give me a bigger prime number. Give me a prime number in 90s, Umar. Is 97 prime? So it is telling in how many attempts? So n by 2, right? Then the fourth developer comes. You can say I can also make it even faster. So what he does is he says a number. So let's say I'll explain this all mathematically if I'll get it. If the number is 100, let's say, what is the number? 100. What is the square root of that number? Square root of 100. How much? 10. 10. So so what we do is to check whether 100 is prime or not, you just check whether the number divides from 1 till its square root. Once everybody will go 2 till its square root. So if the number divides within this range, then it will divide by 100 also. If it doesn't divide in this range, it will not divide by the original number also. Just check till its square root. Let's say one more example. Let's take 36. What is the square root of 36? Yes, 6. So to check whether 36 is prime, just check whether 36 divides by 2, 3, 4, 5, and 6. If it divides by any of these numbers, then it is not prime. So does 36 divided by 2? So it's not prime. Okay. Let's take 81. So what is the square root of 81? 9. Now to check whether 81 is prime or not, what you have to do? Just check whether 81 divides by 2 to 9. So does it divide by 2? Yes. Does it divide by 3? Yes. So it is not prime. So don't need to go till the half also. So don't need to go till 50 to check for 100. Just go till its square root. You will come to know. Okay. So let's take 97 now. Let's take 97. So if 81 is 9 and 100 is 10, right? So where does 97 fall into? 9 point something, 9.9. So let's take 9. Okay, let's come into integer. Now try 97 with 2. Will it go? With 3, will it go? 4, 5, 6, 7, 8, 9? No, right? So we can. So if it doesn't divide by this range, it will not divide by the other numbers also. It's a prime number. So now this person says instead of going till the half, we can just directly go till less than equal to. In the math class, we have a function called square root, and we can just pass the n value over there. Now the 97, which took how many iterations last time? 47, right? And now if I run this, the same 97 will take how many iterations to say it is not prime? In 8 iterations. Getting it, guys? So if you are getting a Samsung S24 for 47,000 somewhere, and some shop is giving the same model, same original for 8,000, well, where will you buy? Now, now this irrespective, it is working on my laptop, which is having 16 GB of RAM. Even if I give it to someone who has 4 GB of RAM, it will still say 8 iterations, right? So this is what you have to understand. So this is what O of square root of n and minus 1, right? Because we are starting from 2. We are starting from 2. So now we have these 4 algorithms. So which was the first one? T of O of n, right? So now we are not concerned with getting the output. We are now concerned with how we can reduce the primitive operations while getting the output, the comparison. Next one was what? O of n minus 2, right? Which was faster. Then the third one was what? O of n by 2. This was even faster. And now the last one is what? O of n. So if I had the value of n as 100, if I had the value of n as 100, assuming, now how many steps would each algorithm take? The first one would take how many steps? 100 steps. Second would take, so this phone is coming at this shop for 100,000. Then second shop is giving me only 2,000 discount, 98,000. Third shop is giving me a substantial discount of 50,000. And the fourth shop is giving me only for 9,000. Because 2 to 10, right? So don't you see there's a significant improvement in the performance with the same code written by different developers, but the primitive operations have reduced substantially. So this you have to present in your interview, that the code which you are trying to show, you have to explain them with regards to which time complexity it is fitting in. So if you can write this code, and if now all these four developers have come for the interview and they all are getting the correct output, all are getting the correct output, and I have only one vacancy, who will I hire? Who would you hire? Yes, yes. So the one whose time complexity is the minimum. So those who are tenured, experienced candidates, experienced candidate have to keep in mind in the interview that you bring this topic up of time complexity. That my code which I write, I make sure that my code is faster. By meaning faster means, will you tell the company, please you give me a good hardware so that my code runs faster. Give me a 64 GB RAM. That is not the meaning of the code running faster. You have to optimize your code. Make sense? So I'll publish this code, and